So we're going to look at number 12 on worksheet number 2. The last one. So we have what appears to be a circular shape. And talking about domain and range, we said the domain were the x values, how far it's stretched to the left and the right. And the range would be the vertical y values, how far it's stretching up or down. And then we have to decide if it's a function. Anyone want to take a shot at what the domain is, what you have for the domain? Maddie?
Negative 5 is less than or equal to 3.
Perfect. So -5. We write, because I'm not plugged in. So she said -5 is less than x, which is less than 3. Why'd you use the less than symbols, Maddie, instead of less than? Say it again. Yeah, there's an open circle. So at -5, we have an open circle. At +3, there's an open circle. And that's the only point that that circle touches. Like it just touches that value, right? At the -5. But it's an open circle, therefore we would just say the less than. So -5 less than x, which is less than 3. Nice job, Maddie. If there was a closed circle there, then we would have that less than or equal to. How about the range? Abby, what do you have for the range?
-3 is less than or equal to y is less than or equal to 5.
Good. Those get the less than or equal to symbols because there is not an open circle at the top and the bottom of that circle. So they are included in the graph. There's actually a point there. So if it's a closed circle, there's a point. Or if there's nothing there, there's a point there. So it just is a kind of continuous at that space. And then is this a function? No. So it's not a function. It doesn't pass the vertical line test. Are there any other questions from worksheet number 2? Number 4? So looking at number 4 from last year, this is called a array. So we have array, not a line, because a line has to go both directions. This is array. Julian, what do you have for the domain of the array?
-infinity is less than x, which is less than or equal to 2.
Perfect. So -infinity is less than x because this graph does have an arrow that takes it forever left and forever up. So it's going to stretch forever to the left and it's also going to continue to rise. And then it stops at the x value of 2. Again, it's equal to that value. That's a point there. And then the range, Julian, what did you have for the range?
-2 is less than or equal to y, which is less than 3.
So it starts at -2, that's the lowest point, and it's going to continue to go up vertically because there's that arrow pointing to make the graph continue beyond where it's dropped. So it's continuing in it like an upward motion going to the left there, so that would go to infinity. Is this one a function? Yes. It passes the vertical line test, therefore it is a function. It's also continuous. The graph that we have here does not have any breaks in the graph. There's not any place where it stops, or it has an open circle. So this is also a continuous graph. And Julian, so you're going to Sure. So 9's a little crazy looking. Have this mound in the middle, 2 little arrows on either side of it. Emma, what did you have for the domain of this one? And why did you say that?
Because even though the ends on the x value, it still has arrows that continue.
Good. So she said even though it looks like it ends, it still has these arrows that are going to continue it on. So So it's going to continue on left, it's going to continue on to the right. So those arrows continue the graph on forever, in this case both left and right. So it goes from negative infinity, less than x, which is less than positive infinity. How about the range? What's the lowest point of the graph? So always start your range at the lowest point. Julie?
The lowest one's 0.
Yeah, the lowest point 0 because it touches the x-axis at -3 and +3. So the y value is 0. It's not going below 0. The x-axis is its point where it starts. So it starts at 0. And then if it has little arrows, those little arrows, besides stretching it forever left and right, they're going to gradually move that graph up as well. So that would continue to go to infinity. So it will continue to move the graph left and right, but gradually it's going to increase and it will get beyond that little bump in the center. So when you see an arrow on the graph, that graph continues. Whatever pattern it's doing, it's going to continue in that pattern. So if it's gradually moving up, it'll continue to move up. Is this one a function? Yes, this is also a function. It passes the vertical line test, and we would say that it's also continuous. There aren't any open circles in the graph. Yes.
Instead of saying negative infinity, could you say all real numbers?
Yeah, so that's a good question. Whenever you have negative infinity to positive infinity, Connor asked if you could say all real numbers. Which is really what negative infinity to positive infinity means. It means every single number that exists. So it would be another way of looking at it instead of saying negative infinity to positive infinity. Connor, do you know how else you can write all real numbers? There's notation instead of writing out all real numbers. Do you know that notation? Not sure. Does anybody know what the notation is for having all real numbers, or maybe you've seen all real numbers written in some way? All real numbers, I think you use this in English. They still use that symbol in English. Yes, and that means like a new paragraph. So all real numbers is an R, kind of like a paragraph symbol, but an R. It means negative infinity, which is less than x, which is less than positive infinity. Like there's multiple ways to write it. But you could also say all real numbers if you have a graph that goes from negative infinity to positive infinity. So it's like the paragraph symbol, but it's an R. So math that represents all real numbers. Or you could write negative infinity is less than x is less than positive infinity. Any other questions? So I would like to look at that if you make sure you place your name at the top of it. I sent you yesterday the solutions to worksheet number 1, so hopefully you took the time to check those. Today we're going to look at the last piece of chapter 2, and that last piece of chapter 2 is called piecewise functions. So we're going to look at graphing and evaluating piecewise functions. And that should be the last page in your packet, or the second to last page in your packet maybe. Oh, none of the, okay. So just a little reminder, Monday notebook quiz. Make sure all of your notes are complete from chapters 1 and chapter 2. If you were absent today, please go to Google Classroom. I have the PDF of every section on Google Classroom. I also have a YouTube video of every section on here at Google Classroom. So if you're absent today, you can get them from the PDF. You can get them from the YouTube video of me talking and writing on the screen. So it's like you're watching the lesson without being here. Also, make sure your homework assignments, the worksheets and the bookwork from chapters 1 and 2, make sure they're in section order, starting with section 1.1 from chapter 1, going through section 2.7 for chapter 2. Like you will not be able to come back and finish it. So you'll have like 20-25 minutes And it should be plenty of time. Like I have mine, and I know I'm a teacher, but mine is just organized in here. So I have my notes and then my homework, my notes and then my homework. It just follows in order. So this is all chapter 1 and 2. I did the notebook quiz in about 10 minutes. Again, I'm crazy organized, but like everything is in here for those 2 sections in order. So it just makes it a little easier to kind of work through. It makes it easier to study. The goal of the notebook quiz is not to drive you crazy. It's not meaningless busy work. It's for you to like literally look through and force you to review before a test. Because then you're kind of looking at a couple of problems as you're looking through and scanning through the notes. So again, that is on Monday. Tomorrow we'll start reviewing for your test on Tuesday. Questions? So just to give you an idea, the notebook quiz is 20 points and the test is 50 points. So in those 2 days, 70 points in the 2 days, which is probably the most that we've had so far in like a quick day or 2 of class. So we are going to look at piecewise functions. So piecewise functions. What word do you see in piecewise functions? Jillian, what word do you see there? Piece. So we're going to have multiple parts or pieces of functions that are going to be graphed on the same xy axis. So not just one equation, but we're going to have multiple equations. However, we're only taking a piece of those or a part of it to make sure that it's a function. So we will be graphing them or evaluating them. Alright, so graphing multiple functions on the same axis, xy axis, and the same graph, coordinate grid, however you want to say that, each with a specified domain. So we've been working with domain. A domain tells you how far a graph should shift left or right. So a piecewise function is going to have a specified domain. It's going to tell you that this equation is only valid for this section of the graph. And if you look at the first example underneath, see a piecewise function is written a little differently because you now have multiple equations to work with. You might have 2, you could have 3, you could have 10, depending on how big and elaborate the function is. So when you see a piecewise function, it's still a function, meaning it still passes the vertical line test. If it doesn't, then it's not a function that we can work with. It would be f of x because each input would have more than one output. So they're saying g of x instead of f of x. That part doesn't really matter. We got these little squiggly things. Those squiggly things mean that you have multiple options to choose from. So the first equation says 2x minus 1. So that's our equation part. And then it says if x is less than or equal to 1. This is the domain here. So when we look at that piece of the graph only works for x values that are less than or equal to 1. So looking at the graphs that you did yesterday, like those graphs were different shapes, different pictures, and that's because most of them were piecewise functions. And they did those weird kind of move from one location to the next. They decreased and then they went back up because of looking at a piece of that graph. So the second one says 3x plus 1 if x is greater than 1. So again, both of those are the domain. So we're talking about x being less than or equal to 1 for the first equation, but the second equation, x must be greater than 1. So this asks us to evaluate a piecewise function. And even though there are 2 equations, this is just one function. Together, put together, they make one function. It wants us to evaluate it when x is 1 and when x is 5. So we're going to do this 2 separate times. So we're going to look at when x is 1 and then also when x is 5. So to evaluate you need to choose the correct piece first before you actually evaluate the problem. And you're choosing that piece based off of the x value. So if x is equal to 1, which domain does that fit in, or does that apply to? So look at the domain. Abby, which one does it work with?
The first one.
The first one. So x is less than or equal to 1. Well, if x is 1, 1 is less than or equal to 1. So you're not evaluating first, you're choosing a piece of the equation first, based off of if the x value matches its corresponding domain. So because 1 is less than or equal to 1, then we can choose the equation 2x minus 1. So we don't plug it into both, because it's one piece. It's either one or the other if I'm dealing with two different equations. So you can evaluate it after you decide the equation you're using. 2 times 1 is 2, minus 1 gives us 1. So when x equals 1, then the y is equal to 1. Because you plug in x, you get out y. You could write it as an ordered pair, 1 equal to 1 is 1. So if you look at the second one, it says x is equal to 5. So again, you've got to choose the correct piece of the piecewise function. And 5 is greater than 1. So we're going to look at that second part, the 3x plus 1. So we're picking a piece to use based off the given x value. Then after you choose that portion of the piecewise function, then you can evaluate. So when x is 5, the y is 16. So if we graph that, you would have a point at 5, 16. 5, 16. We would have a point at 1, 1. Questions? So they might look confusing because you have multiple equations to deal with, but you're still only choosing one of those equations based off of whatever your x value is. So choose first before you actually evaluate. The second type of example at the bottom of your page wants us to graph. So instead of having an equation where you're asked to evaluate, like this one here, we're going to see if we can actually get a picture. And notice there are now 3 pieces up here. So if there are 3 pieces, we're going to have 3 different parts to the graph. There are 4 pieces, you have 4 different parts to the graph. So we are going to graph this piece by piece. And the first one we're going to look at is just the negative 3 halves x minus 1. So think of that as you're just given this is back to section, I think, 2.2.2.3 when we looked at these. We're going to go section 2.3. Y equals negative 3 halves x minus 1. This was still part of this chapter. How do you graph that? So if this was on your test, how would you graph that? Julia?
Negative 1 is the y-intercept.
So negative 1 is the y-intercept. And?
Negative 3 over 2 intercept.
So how would you move with that slope?
You go down 3 and then right 2.
Good. So you could go down 3, right 2. Or we could go up 3 and backwards 2. Okay. So if you have a pencil, I'm going to draw this line in lightly. If you have a pen, really make it like, maybe it's an erasable pen, because we're going to erase part of this line. So that is the line y equals negative 3 halves x minus 1. However, that line has a domain that says x is less than negative 2. So now we have to get the right piece of the line. So we're going to go to where x is negative 2. So on the x-axis, right here is where x is negative 2. And you're going to match that up with your line. So you go to negative 2, match it up with where your line exists. And we have a point there. So right here is my point where x is negative 2. Since it says x is less than negative 2, what do you have to do with the point at negative 2? Odette? Right, so we need to make it an open circle because it said less than. And then we have to decide which piece of this line we want. So if this is x is -2, which way would the x values be less than -2? Yeah, so the piece up here or the piece on the left side. Because if you're on the left, those are the numbers that are smaller. If you're on the right, those are the numbers that become positive. And then we are erasing the rest of the line. And now I have my first piece. So we drew the entire line. We're using the domain to pick the piece of the line that we want to use. Now we're going to try it again. So we have a second equation. And that second equation says x plus 1. So just like Julia said, to graph you start with the y-intercept. So we're going to start with the y-intercept. This y-intercept starts at +1. It has a slope of a 1 in front, so we're moving up 1, right 1. Make sure to always go backwards as well. Down 1, left 1. Okay. So here's my line. Now we're looking at the x from -2 to +1. So just like we did before, you're going to go to where x is -2, match that up with the new line, and it says less than or equal to. So it's allowed to be that point. And then we're going to go to where x is 1, match that up with your line. It says less than or equal to, so we also have that as a point. Which piece of the line are we using? So -2 is less than or equal to x, which is less than or equal to 1. Julian, what piece?
Piece like in between the two.
Yeah, so when you have two numbers, you're using the piece that's in between those two numbers. The rest of it is gone. So looking at the graph, this is a function because it passes the vertical line test. You have a closed point, but an open one above. So that's okay because one point is there, the other one isn't. So it's still a function. It looks weird, but it is still a function. We have one last piece to graph because this gave us 3. And it just has 3. So that just means y is equal to, not x, y is equal to 3. Each one of these can be written in y equals 4. What kind of line is y equals 3? A horizontal line. So you're going to go to where y is 3. Right here is where y is 3. Make a horizontal line because y is just always 3. And then exactly like we've done the last two, you're going to where x is equal to 1, match it up with your graph. This time it just says greater than, so we get an open circle. Greater than means you want x values that are bigger than 1. X values that are bigger than 1 move to the right because that's where your graph is positive. And then the rest of it, we have to erase. So you're erasing everything else. So 3 equations, all lines that we graphed. Graph each one. You're picking a piece of the line. That makes it a piecewise function. Questions? So I strongly suggest that you do your homework in a pencil so that you can erase that piece. Julian?
Do you need to connect them or do you just leave them?
You do not connect them. That's a good question. So there is no connecting. They're each separate pieces. Unless they actually would touch at the same point, then they would connect. Otherwise, they are separate. So there's nothing connecting them vertically. Any other questions? So on the next page, we're going to try and do the exact opposite. You'll see that you have a graph. we're gonna see if we can make our own equation from the graph for our own piecewise function. So we've evaluated it, we've graphed it, now can we create the function from the graph? So we're going to start out with that f of x equals, if there are 3 pieces, then you should have 3 equations. So the number of pieces represents the number of equations that you would have. And I'm just going to start on the left and work right. So if we start at the left here, we have this horizontal line. We just said what a horizontal line represented. So Emma, what is the equation of the horizontal line that's on the left? Yeah, so that equation is y equals 3. So when we come to write our piecewise function, you're just going to write a 3 there. So horizontal line, y equals 4, y equals 3, whatever the y value is. And then we have to write if, and you have to give the domain of that little horizontal line. So Emma, what number does it start with? -3, and it's closed, so less than or equal to x. And then Emma, what number does it go to? Nice. I go over a little bit. And she said it goes to 0, and is 0 less than or less than or equal to? Less than. Because that has an open circle there. So 3 is one equation. If the domain goes from -3, which is less than or equal to x, which is less than 0. Alright, so let's look at the second one. Maggie, what's the equation of this second line right here? The one in the middle. Yeah, y equals 2. So we just place a 2 here. And then Maggie, what's the domain of that little line?
0 is less than or equal to x.
Less than 2. So it starts at the x value of 0, it stops at the x value of 2, and that is an open circle. Alright, so we have one more line to look at, and it's going diagonally. So when it's going diagonally, we need to know the slope and the y-intercept. So what is the slope of the line? Let's start with that, because it doesn't cross the y-intercept. What's the slope of this diagonal line? Mackenzie Myers, what do you think the slope of this diagonal line is? Yeah, it looks like the slope is 1. Mackenzie, how could you get the y-intercept?
You could continue the line down.
Yeah, just continue the line. Make it go the other direction. So she said the slope was 1. So we can just go, instead of up 1 over 1, go down 1, back 1. So that we can continue the line, because we need a y-intercept. And that y-intercept is at +1. So you need the slope first so that you can continue the line to make it cross over the y-axis. So that equation would be 1x, or you could just write x, and then +1. And then Mackenzie, if it starts right here, can you give me the domain?
2 is less than or equal to x, which is less than or equal to 6.
Nice job. So the graph does stop here. It doesn't go on forever. It stops at the value of 6 for x. Questions? I'm going to skip the problem on the underneath that. If you flip the page, I want us to kind of practice some of the problems we just looked at. So we're going to skip the little one there. So on the next page, they want you to evaluate the piecewise function. So we have 3 equations, and they're asking you to evaluate for 3 different numbers. So 0, 6, and 1. Remember, you're choosing the piece first. So pick the correct piece based off of which that x value kind of relates with. What domain does it match to? So your x value has to match in the domain, and then you pick its corresponding piece. So Connor, if x is equal to 0, which piece does that go with?
X is less than 1.
Yeah. So 0 is less than 1. That means we're looking at x squared minus 2. So Connor, if we have 0 squared minus 2, you get negative 2. So y is equal to negative 2. Okay, middle piece here, we have x equals 6. Gavin, which piece does x equals 6 apply to?
X is greater.
Yeah, so 6 is greater than 5. So that means we have 10 times 6, which is 60. And then the third one, Maggie, what's that go with?
10 or negative x.
Yeah, it goes with negative x because 1 is less than or equal to 1, which is also less than or equal to 5. 1 is equal to 1. So we have negative, I guess really it's negative x, but negative 1. Questions? So the second one is asking you to graph, just like we did for our second example. So you're looking at 2x plus 2, graphing that line, graph the whole line, and then erase the piece that you don't need. Remember, starting with your y-intercept, so we have our b value and our slope. And make sure you graph that line in both directions so that you have enough to get the piece that you're looking for. So y-intercept is 2, slope is up 2 over 1. And then it says x is less than or equal to negative 2. So that's the domain. You need to find that domain in the line you just drew. And we have less than or equal to negative 2. Going down to my line, I'm matching it up with the point. Less than is left, greater than is right. Less than or equal to gets the closed circle there. So less than is left. You're erasing the other piece. The second equation, we have negative 3 halves x plus 3. So again, the b value moving up to 3. The y-intercept is negative 3 over 2. So down 3, right 2. Or we could go up 3 and left 2. Make sure that line looks like it's going down. Remember, a negative slope is a decreasing line. And that's for x is greater than negative 2. So Holly, if we go to negative 2, what do we put at that value on our line? Yeah, so we should have an open circle. And then we want the values that are greater than. Greater than is right. I know that line is going down, but that's what y is doing. We want the x. So greater than is to the right, less than is to the left. So even though you're saying, yes, but the line's going down, we're still picking the x values that are greater than 2. Questions? So there's one more problem there. see if you can write the equation of that last one. So it's really two lines. You have the line on the left, the right line on the right. They just happen to meet at that same point. But treat that as two lines. So write an equation for the line on the left, write an equation for the line on the right. So tonight's homework is really what was yesterday on the assignment sheet. Just back a day. So you're not doing a review worksheet tonight. I will give that to you tomorrow. So the first one is a piecewise function worksheet, the second one is the domain and the range worksheet. So looking at this line, Julia, the one on the left side here, what's the slope of the line on the left side? And then if we continue that up, the y-intercept is 5. So 1x plus 5 or x plus 5. And then Julia, what do you think for that domain there?
X is less than or equal to -1.
So she said x is less than or equal to -1. So here's where x is 1, and then it's to the left. If it's to the left, it's less than or equal to. So x is less than or equal to -1. So left is less than, right is greater than. Maybe you want to remind yourself. So less than, you move left. Greater than, you're moving right. The second equation, because this one is going down, the slope is -1. Its y-intercept is 3. So there's a negative x and then plus 3. That is also at 1, but it's moving the right, so it's greater than. And you can't say greater than or equal to because then it wouldn't be a function. So it's just greater than. One gets the solid circle, the other one doesn't. So two equations, different y-intercepts, the slope's the same. They start at the same place because they touch. They meet at that point. So the worksheet with the domain and range, there's just 7 quick little domain and range problems to kind of finalize those. And then the piecewise functions, it's the 3 different things that we've talked about. Have an awesome day.